Ever wondered why ice cubes melt in your drink but not in your freezer? Or why water boils at a lower temperature on top of a mountain than at sea level? The answers to these intriguing questions lie in the fascinating realm of phase equilibrium and thermodynamics. Let's dive right in by exploring one of the most important equations in this field, the Clausius-Clapeyron equation. Named after Rudolf Clausius and Benoit Clapeyron, two giants of 19th century physics, this equation is a powerful tool for understanding how and why phase changes occur. The Clausius-Clapeyron equation is a way of quantifying the relationship between the vapor pressure of a substance and its temperature. In simple terms, it tells us how much the pressure exerted by a substance's vapor changes as the temperature changes. The equation is written as follows: dp dt equals L over T times Vg, where dp dt is the rate of change of pressure with respect to temperature, L is the latent heat of the phase transition, T is the absolute temperature, and Vg is the specific volume of the gas phase. Now, how does one use this equation? Let's say you're interested in finding out how the vapor pressure of water changes with temperature. Step 1. You need to know the latent heat of vaporization for water, which is the amount of energy needed to turn liquid water into steam at a constant temperature. This value is approximately 2,260 joules per gram. Step 2. You also need the specific volume of steam, which is the volume occupied by a certain amount of steam at a specific temperature and pressure. This value depends on the conditions, but under normal atmospheric pressure and at the boiling point of water, it's about 1.67 cubic meters per kilogram. Step 3. Plug these values into the Clausius-Clapeyron equation, along with the absolute temperature in Kelvin. The result will give you the rate of change of the vapor pressure with respect to temperature. With this, you can predict how the vapor pressure of water will change as the temperature increases or decreases. To wrap things up, today we delved into the fascinating world of phase equilibrium and thermodynamics, focusing on the Clausius-Clapeyron equation. We explored the meaning of the equation and walked through the steps of using it to calculate the rate of change of vapor pressure with respect to temperature. Remember, this powerful equation allows us to understand why phase changes occur, such as why ice melts in your drink but not in your freezer, or why water boils at a different temperature on top of a mountain than at sea level. So the next time you see a pot of water boiling or an ice cube melting, think of the Clausius-Clapeyron equation and the amazing science behind these everyday phenomena.